That brings us to our second cluster of topics, which is sea level rise. As I briefly alluded to in the open, we're expecting an extremely active hurricane season, and we're still 2 months away from the peak of hurricane season, so it's very hard to predict these things with great certainty. But that's a situation where we have storms that could be impacting very heavily populated areas along the East Coast. And there's hurricanes even without climate change, right? But climate change provides much more fuel to feed the machine that is the hurricane and can make the situation much worse. On top of that, we're faced with the relatively slow process of sea level rise, where global mean sea levels could be on the order of up to 1 meter above pre-industrial levels by the end of this century, if not sooner. And when you think of storms like the kind of storms that we've dealt with in the past or may deal with this year that produce storm surges on their own, even with a small amount of sea level rise, a moderate amount of sea level rise, no sea level rise, you think of those factors acting together, and you think of a strong hurricane season in a world where the mean sea level is a half meter above what it is now. And that's a very disruptive potential part of our future. And I think it's very important that we have two students who focus squarely on this issue. First, we have Tiliouine. He's a graduate of the University College London. He majored in geography, and while he was there, he did an undergraduate thesis on small-scale fisheries, went to Madagascar, survived a bandits attack, and completed his thesis, turned it in, and was well received. He was accepted to our program and has really taken a strong interest in a lot of things, including international policy and sea level rise, and I think hence the choice of topic here. So it's my pleasure to introduce Oliver. The floor is yours.
Thank you for the introduction, Corey. Yes, I'm going to be presenting my capstone entitled Rising Tensions, the Impact of Sea Level Rise on Maritime Zones today. So just to give you guys an outline of what we'll be covering in my talk this afternoon, I'll start off with just a bit of context to let you know what exactly are some of the things that I'll be referring to throughout the course of the presentation. Then give you a background on the sea level rise projections that I used in the modeling that I did, then explain what the model I used was and how it came about, cover the United Nations Convention on the Law of the Sea, which is the policy side of things, which my projections then relate to later on, go through my methods and how I use the model, show you some of the results that I was able to create, and then the discussion will focus on what the results show and then the problems that they reveal about the Law of the Sea as it stands before concluding, and then opening the floor for some questions. So just to give you guys some background on what I'm talking about, so I'll be referring to exclusive economic zones, or EEZs, frequently throughout this presentation, and those are, as you can see in the chart in the top right of the slides, they go from the 12 nautical miles, which is the end of the territorial sea, to 200 nautical miles out off the coastline. And the baselines there that it refers to are the mean low water marks, as you can see on the chart above. So an exclusive economic zone gives the state that it belongs to sovereign rights to the natural resources in the seabed, subsoil, and superadjacent waters within that zone. And they also have the right to exploit the water, currents, winds for energy production. However, unlike in the territorial sea, they can't limit navigation or overflight there. And then the map down here in the bottom right shows EEZs around the world, and then the ones in red are contested areas where countries have a dispute over who it should belong to or how much they should be able to claim. So you can see in Southeast Asia down here, there's contested areas and also a number of EEZs that are bordering other EEZs, which is an area I'll be looking at later on in the presentation. So then the projections. So what sea level rise projections did I run on the models? So I used 0.5 meters, which is the top of the likely range for RCP 2.6, and that's the representative concentration pathway. And these basically show emissions to 2100. So RCP 2.6 involves reducing emissions and actually including geoengineering to remove CO2 from the atmosphere as it is. So this is like if everything was fantastic and humans are able to achieve what we want, we would see RCP 2.6, and the top of the likely range for sea level rise, despite that, would be 0.5 meters. Then RCP 8.5 is the most extreme scenario, where emissions continue going, we continue to exploit oil and gas relentlessly, and that sees obviously a lot more sea level rise. So the top of the likely range there is 1 meter of sea level rise. And then there's also more recently 2.5 meters of sea level rise by 2100 has been proposed as a worst case scenario. And this came from the California Ocean Protection Council's working group reports on sea level rise for California. And this basically uses emissions from RCP 8.5, but then includes extreme Antarctic ice sheet responses to the warming. So obviously there's an awful lot of ice in Antarctica. If it was all to melt, it would raise sea levels around 60 meters around the world. And this scenario basically shows everything going wrong and what could happen with ice sheets in Antarctica, resulting in 2.5 meters of sea level rise by 2100, as you can see on the chart that I've got on the screen. So then a little bit of local context, which isn't so relevant to exclusive economic zones, but here is a map of what San Diego would look like. The coastlines in San Diego with 2.5 meters of sea level rise. So you can see here, Mission Beach is gone, essentially. Coronado Island, where there's important military bases, also suffering a lot of lost land. Chula Vista down here, and then also Imperial Beach losing a significant amount of land. So these aren't necessarily relevant to exclusive economic zones. However, it just shows you the local area here and what would happen. And it's an example of a projection that I was able to make. So then how did I do these projections? I used a digital elevation model, which came from Climate Central, which is a research organization on the East Coast. And they developed a model called Coastal DEM 90, which is basically an improvement on the existing digital elevation model, which was from NASA, the SRTM model. So they had satellites and radars, which basically measured the elevation of different parts of the world. But this resulted in significant error because of differences in topology, the presence of vegetation, buildings, and then also some random noise. And this resulted in error that basically meant it was sort of from 3 to 20 meters of error. And that's not very useful when we're looking at sea level rise projections by 2100 of 0.5 meter to 2.5 meters. If the error is 3 to 20 meters, then it's essentially not going to be very useful to run those projections on that model. So what they did at Climate Central was take LiDAR data, which is more precise remote sensing information, which existed already for the USA and Australia, and they compared it to the SRTM model and then calculated the error in the USA and Australia and then applied this via machine learning to the rest of the world to improve the accuracy of the DEM. And I'll dive a little bit deeper into what exactly the DEM is in a couple of slides. So then for the policy side of things, this is focused on the United Nations Convention on the Law of the Sea, which was signed in 1982 in Jamaica and became effective in 1994 when it was ratified by the 60th party. It's now been ratified by 168 parties, with other parties or other states such as the US recognizing it as general international law, but not having signed on to the treaty. And it defines the rights and responsibilities of nations with respect to their use of the world's oceans. And particularly for this project, the exclusive economic zone, which is, as we were talking about before, the baseline is 200 nautical miles. So the low water line marked on large-scale charts are officially recognized by the coastal state. However, being written in the 80s, it didn't consider the impact of sea level rise, the impact that sea level rise could have on the text in the treaty, and it doesn't consider the baseline changing as a result of sea level rise, which is what I will be showing in my projections. So I used the digital elevation model, which I've discussed a little bit already, and this is formatted of raster data, which is a matrix of cells arranged in a grid, as you can see in the top left. And each cell has a unique value. In this case, it's elevation. And the data points are split by, the files were split into 1 degree by 1 degree files in order to have files that weren't too large to be able to work with on a computer model that I can access, on computers that I could access. So then from this DEM, I created contour lines, and these were done at 0 meters, 0.5, 1, and 2.5 meters. The 0 meters being the current baseline, the current coastlines, and 2.5 meters, 0.5 meters, and 1 meter being the projected sea level rise coastlines. And then I had to select the seaward contour lines in the model to represent the coastlines and not have sort of hills that were close to the coast, but not necessarily relevant for sea level rise. And I was able to compare the current coast, which I created from the 0 meter contours, to the 0.5, 1 meter, and 2.5 meter projections. So then this is what the maps that I was able to create look like. So here you can see in green is the new coastlines under 0.5 meters of sea level rise, and then the current coastlines in black. So where you can see the black ones, that's because the coastline has retreated and the green is no longer covering the original black coastline. So that's for the Madagascar and Mozambique under 0.5 meters with so not an awful lot of change here, but still in places like where I'm showing you the pointer, up to sort of 10 miles of change on some peninsulas, and then maybe 5 miles up here. So still significant amounts of land being lost. And then as we ramp up the sea level rise projection, obviously you see similar areas being affected and being affected more, and then also new areas emerging that are going to be seeing change in the coastline. And then the most extreme scenario of 2.5 meters obviously is showing a lot more land lost, and it is again focused in delta regions with low lying land already. And here you can see sort of maybe 25 miles of land being lost in places, which would obviously have an impact on the EEZs, which would be marked throughout the ocean. And you can also see it affecting Madagascar over here. So then a region that I looked at was Southeast Asia. And here you have obviously lots of island states, lots of low-lying land, important fisheries, and lots of EEZs that border EEZs of other states, importantly. So under 0.5 meters, you can see Indonesian coastlines here in the Celebes Sea, heavily impacted, and also down here in Indonesia with Cambodia, Thailand, and Malaysia also seeing impacts there. And then as we increase the level of sea level rise, the changes have become more dramatic, as you can see. And then for the most dramatic scenario of sea level rise of 2.5 meters, you can see an awful lot of land here being lost in the Mekong Delta of Vietnam. That's sort of 200 miles being lost there. And then regions such as this one in the south of Indonesia here, there's an awful lot of land being lost, which is obviously awful for coastal communities and for the country. But for this project, it's not so, regions like that aren't so important, as this island is also in Indonesia. So all the water in between is Indonesian. And there'll be no sort of disputes arising as coastlines retreat, and this economic zone should also retreat with them or not. So here's just a zoomed in map of Vietnam, where you can see again the extreme amount of land being lost to sea level rise under 2.5 meters. So basically what my results showed me are that low water marks are going to change significantly, and the Law of the Sea Convention is silent on what happens to zones as a result at the moment. So then I had to think of what this means, and perhaps what is the best solution to the problem that I've identified. So I was thinking using coordinates, not low lines, would be the best way to identify EEZs and perhaps to fix them in place as they are now. However, that would allow states having to have EEZs larger than 200 nautical miles, as if you fix it where it is, but then the coastline retreats, there's going to be more than 200 nautical miles of ocean from the new coastline to the outer edge of the exclusive economic zone. However, this would counter the loss and damage to the coastlines with larger marine territory, and also not losing marine territory on top of losing valuable coastline. It also removes the issue of border tension, as EEZs won't be moving around, so there'll be less space for disputes to pop up regarding that. And it presents issues regarding the ownership rights and future fishing quotas and resource exploitation as well. As a country could say to another country here, you can come and fish in our EEZ for the next 10 years if you pay us this money. But then if their EEZ changes, obviously the rules, the terms in that contract are no longer the same, because they might no longer have the same EEZ to sell the rights to in the future. However, there are problems with this. As I said before, UNCLOS states that an EEZ can't stretch further than 200 nautical miles, and states set to be submerged in cases like the Maldives, which is quite likely to be losing if not all of its landmass this century under sea level rise projections. So when they're submerged, they would only exist as artificial islands that they were able to create. And currently, the law of the sea says that an artificial island can't generate an EEZ either. And then I suppose the most obvious problem is you can see on the red map, on the red sections in the map here, that states can't currently agree on what EEZs are right now. So trying to fix them in place to have them long lasting won't work until you can agree on exactly which EEZ areas belong to which countries at the moment. So it seems that it's quite unlikely to see an agreement reached on updating the treaty. However, I do think that fixing zones using the coordinates minimizes the impact of sea level rise on small island developing states. So then I had to look at perhaps there is already pathways within the treaty, within the convention as it is, that could result in fixed zones being in place. So here, the Vienna Convention on the Law of International Treaties becomes relevant, because where states have had a dispute over their EEZs and each claim, perhaps if they're opposite coasts, they might have come to a bilateral agreement that sets the boundaries in place. And under the Vienna Convention on the Law of International Treaties, states in bilateral agreements can unilaterally terminate the agreement if there's a fundamental change in circumstances. However, there's also a clause in that article of the convention that says they can't do that if the treaty is related to boundaries. So that means any country that has any two states that have entered an agreement about their EEZs as they are can't exit because of a change in coastlines, which means those will be fixed in place as they are. However, I haven't been able to see how island states that are set to be submerged would be able to use something like this, because that's not an agreement. Their EEZ doesn't exist as a result of an agreement between themselves as another state. It's just following the guidance of the convention. And it's the same for EEZs that border international waters. So basically any existing maritime zone that doesn't exist as a result of a bilateral treaty, it's not so clear as to what will happen to them in the future as sea levels rise, whether they should be moving or not. So then to conclude, I do think that amending UNCLOS to allow for the fixing of maritime zones based on the current coordinates would be ideal. However, it's probably not a solution that will be possible, unfortunately. Fortunately, the Vienna Convention can be used to fix EEZs that are part of bilateral agreements, but as I was saying, for islands set to be submerged, where the baselines will be erased, not just moved, things do seem a little bit more uncertain, and that's the same for EEZs that border international waters, as it will be up to the discretion of judges with jurisdiction over issues regarding the United Nations Convention on the Law of the Sea to determine that. And then perhaps those decisions will run on and be referred to in future disputes. So it's up to sort of what judges have jurisdiction over these disputes come to the conclusion of. So then I just wanted to give my acknowledgements to my committee, which was chaired by Dr. Mark Merrifield, and then I had Corey Gabriel also helping me a lot with the policy side of things, and then Heidi Batchelor was invaluable in allowing me to create the maps and run the simulations on the model that I was using. And I would also like to thank Amy Work from the UCSD GIS library, as she, with Heidi, helped me an awful lot in the projections, and then Dan Reeser from Climate Central, who allowed me to share the model. Allowed me to use the model. Thank you.
Wonderful, Oliver. That was a wonderful presentation. As you may see in the Q&A, we did get some great questions. Unfortunately, we did go a little bit over time, so we won't have time to address those in person. However, I'm getting email addresses for those so that you can follow up with John and Larry afterwards to discuss that and answer their questions on the back end.